This second video for Chapter 2, we're going to look at another way to display our numeric data, and that is with the histogram. Once again, a histogram is a type of graphical summary or graph for numeric data, just like the dot plot was. Instead of looking at the individual data values, the observations are grouped together into bins, and bars are drawn to show how many observations lie in each of these bins. The histogram helps in visualizing patterns, such as what's typical, what's not typical, with the variation that we see in our data. Now, a few things to note about these bins that we're talking about. So the bins pretty much refer to a range of values. So we don't want to look at just the individual data points, but group them together sort of in a range of values. So if you're looking at the prices of new cars, you might look at cars that cost $10,000 to $20,000, $20,000 to $30,000, $30,000 to $40,000, and $40,000 to $50,000. Those would be my bins. And these bins, they need to be of equal width. Those bins that I just listed, they were widths of $10,000, $10,000 to $20,000, $20,000 to $30,000, and so on. I wouldn't want to go $10,000 to $20,000 and then $20,000 to $25,000, have a $10,000 bin and a $5,000 bin, but they need to be equal in width. And then we would see, well, how many cars are in each of those price ranges? And we could begin to see, well, what's a typical price for these cars? So an example of a histogram that's already been created is here. In this table from our textbook, I have 60 IQ scores for fifth graders. Now this is numeric data. Note that the data consists of numbers, and the average of these numbers would have a meaning. It would make sense to find the average IQ of a fifth grade student. But as it stands, I can't really see, well, what's a typical IQ score for a fifth grader and what's not a typical IQ score? What's the high, what's the low? I've got to dig a little bit. So the way I could really begin to see the patterns is to put this into some sort of graph, and we've done that over here with a histogram. Now, this is a histogram. It's not a bar graph. We'll talk about why shortly. But my bin widths, I can see across the bottom. So it looks like this starts about 75, and this would be 85, and this would be 95. And the way these bins work is that this first bin, this first bar is from 75 to 84. Then the next one starts at 85 and goes to 94. And this third bin goes 95 to 104. You can see we've got some counts of students across the side, 5, 10, 15. So this first bar goes up to 2. So it looks like there are 2 students who have scores between 75 and 84. And if we look carefully, we can see in this data set there are 2 students between 75 and 84. That would be the 81 right here and the 82 right here. There are no other scores in that range. The next bar, slightly higher, looks like it's 3. I should find 3 data pieces between 85 and 94. So let's do that, between 85 and 94. Here's 94. Here's a 90. There should be one more. Here it is, 89. That's why this goes up to a height of 3. This third bar goes up to 10. There should be 10 students who have IQ scores between 95 and 104. The tallest bar is this 105 to 114 bar. It's above 15, maybe there are 16 students. Then it begins to go down on the right-hand side. And if we look at this final bar, it's shorter than the first bar, so it should just be one student in this. This would be 145 to 154. If I comb through my data, there's only one number in that range, and that was this first score, the 145. That's the highest score. Now we have this histogram because it's helpful. It allows us to see patterns. I can see, well, most fifth graders would have an IQ between 75 and 154 or 155, but the most typical IQ scores appear to be around this 105 to 114 range. That's where most students' IQs will be. It might be a little bit higher, a little bit lower. And I don't want to look at the individual values here. So number one, I've got a lot of data. I've got 60 data pieces. And number two, there's not a huge difference between an IQ of 106 and 108. They're close enough that I could group those together in the same bin. So we just kind of group those together. Now there is a spin we can put on the histogram, and that is we can make it into a relative frequency histogram. So in a relative frequency histogram, the vertical axis along the left-hand side represents percentages rather than frequencies. The frequency is the number of times something in that bar or bin occurs. Rather than looking at did it occur 5 times or 11 times, we're going to look at what percentage of the time it occurs. We looked at percentages in chapter 1. It's a reminder to compute the percentage, aka the relative frequency. Divide the frequency by the sample size. The relative frequency histogram will always have the same shape. It'll look the same as the regular frequency histogram, only the vertical axis changes. And we can see that with this final example in this video here. Along the left-hand side, I've got my data. And on the right-hand side over here, I have 2 histograms, and they look very similar. There are just a couple things that are different. Number one, they're different colors, of course. But number two, it's what's along this vertical axis on the left-hand side. Here I've got the frequency. How many times did we see this occurring? Compared to here, the relative frequency. That's another way to say the percentage of times this occurred. First, let's look at how this frequency histogram was created. So my bin widths go from 0.7 to 0.8, 0.8 to 0.9, 0.9 to 1.0. 0.7 is in this first bin, 0.8 is in the second bin. So I want to see, well, how many players were between 0.7 and 0.8? So if I look along the left-hand side, these values, these 1, 2, 3, 4, 5, 6 values, these are all in between 0.7 and 0.8. Note that this goes up to 12 and not 6 because there are a total of 12 players along this side. You had one player in the NCAA soccer players who scored 0.727 goals per game on average. You had 3 players who scored 0.737 goals per game. 3 players who scored 0.75 goals per game on average. 1 player at 0.762, 2 at 0.765, and 2 at 0.789. If you add these together, 1 plus 3, that's 4, plus another 3, that's 7, plus this 1 is 8, 10, and then 12. So this went up to 12. The next bar, the next bin from 0.8 to 0.9, it looks like it goes up to 4. Well, there are 4 values in between 0.8 and 0.9, 0.813, 0.833, 0.875, and 0.889, and there was only 1 player in each of those. So that's why I want this one up to 4. The next one, it's a little bit shorter, it only goes up to 3. that 0.9 to 1.0, 0.909, 0.941, and 0.947 are all in between that. That's why that goes up to 3. And there are 2 in the 1.0 range. There's just 1 in the 1.1 range, so that goes to 1. There's just 1 in the 1.2 range. So the 1.2 to 1.3 bar went up to 1. Note that there's a gap in the histogram at 1.3 because no player had 1.3 as the average. This final player had an average of 1.4 goals per game. So that 1.4 goes into this bin, this bar. The green histogram, the relative frequency histogram, looks very similar. The only difference is we have these percentages along the side. If you add these numbers together, that is going to give you 24 total players in this sample. 12 plus 4 plus 3 plus 2 plus 1 plus 1 plus 1 is 24. And if you take 12 out of 24, well, that's 50% of your players. So this first bin went up to 0.50. If you take 4 and divide it by 24 to get that percentage, that decimal is 0.1667, about 16 or 17%, and that's about what this bar, this bin, goes to. If you take 3 divided by 24, that's going to give you 0.125 or about 12.5%, and that's what the third bar goes to. And that's what we did for the rest of these bars. Took the 2 divided by 24 to get the height of this one, and then 1 divided by 24 to get the heights of these 3. And again, there's this gap because there was no 1.3 value over here. So this wraps up what we need to know about histograms. Just a few things to note. They display numeric data. You have numbers across the bottom. Number 2, histograms are different from bar graphs. We'll talk about bar graphs later on in another video, but in histograms, the bins, these bars, they always touch unless you have a gap due to a missing data value, like there was no 1.3. Other than that, the bins, the bars are always touching one another. You have numbers across the bottom. It's numeric data. Again, these are histograms, not bar graphs. Those will come in another video.